Hello, everyone. In this clip, I would like to talk about these three statements. Which one is true, which one is false, and why? Okay, so first of all, let's understand what it means. Starting from the first one. What is the meaning? Okay, when we look at a statement like this, okay, there's no specific requirement about the numbers. And in this case, it is assumed this statement is stated in the domain of all expression involved. Once again, a statement without any explicit specifics about the involved variable, it means that the statement is true in the domain of the entire statement. All right, so let's look at the domain for this expression, this statement. On the left-hand side means an operation, okay? An operation which determines the domain, okay? So we have input x, and x would be squared, right? That's the order of operation. So after x being squared, and we take square root, and then it produces a result. And the right-hand side obviously can be any real number. And the left-hand side from that statement, it can be any real number, because any real number after it's been squared is going to be at least 0. So the second operation guarantees that x squared is going to be at least 0, and a number that's at least 0 can be taken square root, and we're going to get a real number. Okay, so this statement says, okay, since the domain is all real numbers, so this statement basically says this statement is true for all real numbers. Okay, sometimes, okay, we are told, okay, sometimes we are told the statement for any real number x. Sometimes you're given something like this, sometimes you're given just something like this. In truth, these two meant exactly the same. These two mean exactly the same. Okay, because the former by default is a statement referring the domain, and the latter spell out the domain, and that's what it means. So these two statements essentially are the same. Now, the question is it true? Okay, mathematical truth. So before we talk about what is the criteria for truth, right? What is the criteria for truth in math? The criteria for truth in math is if true, always true. If true, always true. So when we make a statement, if it is true, it should be true for any case and all the cases. And as a consequence, if it's false once, false. The mathematical truth is judged very simply. If it's true, it has to be always true. False once, it's false. So now let's see, we're going to use this criteria to judge whether this expression is true or not. is it? Okay. So what I need to do is that if I think it's true, and I should demonstrate it's true for any real number, i.e. positive number, negative number, 0. And if it's false, I only have to demonstrate it's been false once. If it's false once, then it's false. Okay. So with this criteria, and I'm going to give you an example. So let x equals to -1. Well, x equals -1, the left-hand side would be equals to, the left-hand side would be equals to replacing x by -1. By order of operation, right? By order of operation, -1 squared is -1 times -1 equals to 1, and that equals the square root of 1 is 1. So that's on the left-hand side of the statement. On the right side of the statement, on the right side of the statement, it's just -1. If the statement is true, so if it is true, right, in this case, we got 1 equals to -1. Therefore, the assumption for it is true is not right, because 1 equals -1 is not true. So this latter is false. So we have a counterexample at hand. Okay, so once we have a counterexample, that means false once, therefore it is false. And at this point, we can say the statement is false. It's false. Okay, but however, this is a very, very common mistake. The calculus textbook author, who's the author of a very popular calculus textbook for many years, for decades, he ranked this mistake as #1 mistake in calculus. #1 mistake in calculus. And how to demonstrate it's false? Well, you just have to give a counterexample, right? So this contradiction demonstrated that that statement is false. Okay, then what is true then? Do we have something that is true that is related to the square root of x squared, right? So for this matter, we're going to consider some cases. So what will make it true, right? So that it is a true statement, or do we have such an expression? Do we have such a conclusion for any real number x? Okay. In this regard, we need to look at the fact that x can be all real numbers. So we're going to consider if x is positive, if x is 0. So we're going to consider 3 cases. If x is 0, right? X equal to 0, or x is less than 0. We're going to consider all 3 cases to see what we come up with. What do we come up with? Okay, so we're going to have 3 cases. 3 cases. Because if we consider all real numbers, then they're just categorized into these 3 cases. If x is positive, right? If x is positive, square root of x squared, and we're not proving it, right? Right here, we're not proving it. We just demonstrate and analyze. Okay, maybe you can see this as statistically. If x is equal to 2, 2 squared is √4, √4 is 2. right? Because we're choosing numbers in the category of positive number. If x is 5, and this is going to be 5 because root 25 is 5. It looks like if x is positive, the square root of x squared is going to be x. It is true, right? Now, what if x is 0? If x is 0, so the 0 squared, and that's going to be 0. So these two cases can be put together as one case, right? So in x greater than or equal to 0 case, and the square root of x squared is equals to x. But what happens if x is negative? Well, x is less than 0, right? What are we going to see is that the square root of a negative number, say if x is a -1, right? And in this case, the square root of what do we see? The operation is going to be like this. And it's 1. So the result is opposite to -1. Okay, the result is opposite to -1. If we have -2, and this is going to be 4, and it's going to be 2. And the result is opposite to -2. And we can see, we continuously trying this, and we found the same pattern. We found the same pattern. So if I put a -3.5, and then this is just going to be 3.5 squared, okay? And the answer is going to be 3.5 because -3.5 squared is the same as 3.5 squared. So no matter what negative number we put in, okay, the answer is always going to be the opposite of x. It's always going to be the opposite of x, okay? So in truth, if x is greater than or equal to 0, the square root of x squared is x. If x is less than 0, the square root of x squared is -x. And in summary, okay, in summary, actually we are getting the absolute value of x, right? We get absolute value of x. So, and if we use this to test drive, it works every time. It works every time because the absolute value of x, when x is positive or 0, the absolute value of x is the same as x. When x is negative, the absolute value of x is its opposite. Okay, so we have another video on absolute value. So this will be true. This is true. Okay, so now we're going back to these identities, to all these statements. So this is false. Okay, this is false. Okay, and we know that this is false. So what is true? To correct it, it is equals to absolute value of x. Now, how about the second one? The second one. The second one, let me do it here then. Okay, let me do it here then. Okay. The second one, is it true or false? Well, you will also discuss it for x is greater than 0. You consider these three cases: x greater than 0, x equal to 0, or x is less than 0. The idea is the same. So we're going to consider these three cases. Okay, so let me write it down. Okay, if x is greater than 0, right? If x is equal to 0, we're not proving it, we're just showing it by example to come up with the conclusion. And if x is less than 0, right? So what we found? Oh, domain is all real numbers, right? Domain is all real numbers. when we choose positive numbers, we have 2, and this is going to be 2, right? If we get 5, and this is going to be 5. So they're always the same. When we have, so when x is positive, it is true. How about for x equals to 0? Well, that's also true, right? Next case, what if x is negative? X is negative. If I have -2, right? Cubic root of -2 to the power -3, that's equals to cubic root of -8. And that's going to be -2. Oops. It's still true. And you can try -3. That's going to be -27. It will be -3, right? So the cubic root of any number, whether it's negative, positive, 0, you take cubic root and you take cubic root of the power. Let me say it again. You have cubic root. You have cubic power of a number, and then you take the cubic root of the same number. Okay, you take power 3 of a number, and then you take cubic root of that power. You get the same number. So whether it's positive or negative, it's always the same. So this is true. This is true. So this is true. Last but not least, this one we get to use a lot. Is it true? Well, first of all, before we move forward, what's the difference between this piece and that other piece, right? One is a square before, right? Before the root is taken, and the other one is taking the root and then square the root. If you look at the order of operation, if we look at the order of operation, hold on, let me put it here. This is true. Okay, this is true. So we don't get confused. All right. Now, what's the difference between these two? Right? What's the difference between these two? One is square inside and the other one is square outside. Well, the difference, I'm going to put it in a table. I'm going to put it in a table to demonstrate the difference. Okay. So let's see, I'm going to just need 2 rows. Okay, one is for root x and then squared, and the other one is the square root of x squared. So the square is done in different order. Let's look at the first one. The first one, the order is that given an input, we're going to take a square root of that input. Okay, and then after that, we square the square root. The second one, we did this earlier, is that we take the input and we do the x squared, right? X squared will make any real number greater than 0, and last, we take the square root of this squared number. So because this order of operation are different, and this operation determines the domain, okay? Because for input x and then taken square right away, we have to guarantee x must be greater than or equal to 0. On this one, x can be any real number because it will be squared before it is taken square root. Okay, so here this symbol means in, okay, belongs to, okay. All right, so this tells us that when we look at this expression, right, it is implied this statement is claimed in its domain, and its domain is x greater than equal to 0, and therefore it equals to x. Is it true? Yes, it is true. Okay, you can try different numbers, but this time when you try different numbers, the number you can try has to be in the domain, and it is true. Okay, so this is true. So now in summary, we got these three statements. This is a false, and the other one is true. Okay, you need to get familiar with this because we're going to use this all the time. And the second one is true, the third one is true. So false, true, true. That's all for this clip. Thank you for watching.